Bismillahirrahmanirrahim. Assalamu alaikum and welcome to another lecture on work study and methods engineering. We are on module 1. We are discussing some basics. In the previous segments, we discussed what is the focus of work and process design, what is productivity, its types, how to calculate productivity, and we also saw cost perspective of a process or a system. In this lecture, we will discuss three important concepts related to this course, and they are Muda, Mura, and Muri. Learning objectives of this lecture are to understand what is value and what is waste. These are two just opposite words. Understand the three M's that need to be addressed in order to improve a system. So they are Muda or waste, Mura or unbalanced, and Muri or overburdened. And we will discuss seven waves or seven types of Muda. And we will also discuss how we can eliminate or reduce those seven wastes. So let's first define what is meant by the word value. Value is what a customer is willing to pay for. So it is defined by the customer. The word value added means the difference between the cost of inputs and the value or price of outputs. So the more is the price or value of output, the more is the value added, or as we discussed in the previous segment, that the lesser is the cost of inputs, greater will be the value added. Now let's take a very simple example. So we have a wheat crop that is ultimately converted into bread. So there are different steps that are followed. So this is converted into flour and then it is packed and baked and so on. So at each of these stages, some value is being added. But once it is being transformed in from one form, let's say from here to another form, that is called the form value. The shape or the utility or the or the worth of the product is increasing because of change in its form. So that is why it is called form value. You can also see that this product is being transported or moved closer to the customer after different phases. So that is called place value because the product is now closer to the customer. So because of that, the customer is willing to pay more for that product because it is easily available. So just opposite to the word value or value addition is the word waste or muda, something that the customer is not willing to pay for. So we have to reduce it. As we discussed with the help of this figure in the beginning of our course, that the steps or processes where the shape of the product is being changed, the geometry or characteristics are being changed, that is the value adding step or process where the form is being changed or form value is being increased. Whatever is happening in between the processes, whether in terms of queue or wait or delay or transportation, or even unnecessary motions being performed at these workstations, they are all examples of muda or waste, and we have to reduce or eliminate them. And we will see that that is a huge proportion of time spent in the manufacturing life of a product, the time spent between processes or unnecessary motions at a workstation or at a process. So muda mean waste, any activity for which the customer is not willing to pay for. Muda is just the opposite of value, which is simply what a customer is willing to pay for. There are seven different kinds of muda: transportation, inventory, motion, waiting, overproduction, overprocessing, and defect, and we will discuss each one of these very quickly. First, transportation, unnecessary movement of parts or people between processes. So that is transportation. Examples could be many. Building a cutting department and stitching department at opposite ends of a garments factory, then keeping it that way. So there is a precedence requirement in any manufacturing setup. So there is an activity that is performed before the other activity. So the activities that are to be performed in a sequence, one after the other, they should be close together physically as well. There is a lot of transportation in a job shop or the jobbing process that we will discuss in the next lecture what it is, because the routing of each product is different than the other. So one of the goals in a job shop is to actually minimize the transportation. The reason of unnecessary movement of parts or people between processes or the waste of transportation is generally the poor layout design. So by improving the layout, we can reduce transportation significantly. Transportation, and we will see for other wastes as well, create other wastes. So if there is unnecessary transportation, it can result in damage of the part, or it can result in production delays as well. So a waste can cause another waste to produce. So the solution is to relocate the processes. That is to improve the layout. So it is best that the layout, once it is being made first time before the plant is actually constructed or before a department is in action, once machines are being set up, the layout should be made with caution and keeping the principles of an effective layout design in mind. And once the layout has been improved, then we have to introduce standard sequence of transportation in order to avoid any confusion or any damage during uh, unnecessary transportation. So we will discuss the layout design in great detail in one of the topics, but layout here we are talking about the factory layout, the position of different departments with respect to each other, and the position of different machines and processes within a department. But there is another type of layout, that is workplace layout. We will also discuss this type of layout. I mean, what is the arrangement of different items at a workstation, where the raw material is placed, where the worker is sitting, where is the machine, where the product being made by the worker is being disposed, and so on. So this factory layout actually focuses on reducing this waste of transportation, and workplace layout is more concerned about the waste of motion. The second waste is inventory. Inventory is defined as number of flow units in the system. So these are products or semi-finished items in the case of manufacturing organizations, number of flow units, and in the case of service organization, these are the number of customers in the system. There are three types of inventory: raw material, work in process, and finished goods. And here we are more concerned about the work in process inventory. So we are targeting all three types of inventory, specifically work in process inventory, to be reduced. So we discussed this in service sector. The customers within the system are the flow units. So work in process inventory in the case of service sector will be number of unserved customers waiting for service. Or it could be, for example, other things other than the customer. So these could be the loan applications. Uh, that is also example of flow units or inventory in a system in the case of a service organization or a service process. Increases inventory cost. So the increasing number of flow units also increases the cost. Increasing the inventory in the system also increases the waiting time. So we have an equation that is inventory, average inventory in the system is equal to flow rate into flow time. So that is called Little's law. So it is a very important law that we will discuss in the final module. So greater is the work in process inventory in the system, the greater is the flow, greater is the flow time. So we can look at an opposite way as well, that Greater is the flow time, greater will be the inventory in the system. Or in very simple word, we can say that inventory in the system is directly proportional to the flow time, or flow time in the system is directly proportional to the uh, inventory in the system. So greater is the inventory, greater is the flow time, greater is the waiting time, and the queue will build up, and overall inventory turnover, that is a very important indicator of a performance of a system, that will reduce. So solution is that we have to make the flow smooth in the system. We can use a pull system if possible. We can use other techniques like just in time or vendor managed inventory if possible. So we will discuss these concepts as we move on. The third waste is the waste of motion, unnecessary movement of parts or people within a process. So in transportation, it was between processes. The motion is the movement within a process. It is the result of a poor workstation layout, as I mentioned. So the arrangement of different items at a workstation is not appropriate. There are two strong methods to reduce the waste of motion: the ergonomic principles, and one actually subset of those principles is principles of motion economy. And we will discuss these principles in detail in, in one of the following lectures. So arrange people and part around station with work content that has been standardized to minimize motion. So we have to standardize the process. As we discussed, there are different elements of a standardized work, and one of them is the steps that are to be performed and their sequence. And once we have standardized the process, next step is to actually further optimize it by reducing the number of steps or number of motions required. The fourth is the waste of waiting, underutilizing people or parts while a process completes a work cycle. Line stoppages are very common observation where people where the production stops because of problem on an assembly line. Waiting is very common in service sectors as well. So job shops, as I mentioned, have a lot of transportation, but they also have a lot of waiting. So waiting time exceeds processing time in most manufacturing operations. We will see that graphically in one of the following slides, that actually the time for waiting and transportation is a lot more. It's huge in proportion than the time that is actually spent on a manufacturing operation. Now this waiting can happen at the resource, or it can also happen at the customer level. So sometimes the resource doesn't have anything to do. An idle, for example, person in a bank or some other service organization who doesn't have the customer to serve, but it could be opposite as well, that that resource is too busy and a customer has to wait in the queue. So same could happen in manufacturing organization, that a machine doesn't have any work to do. So that is the waiting time at the resource, or machine is too busy, so the raw material or work in process is waiting. So that is the wait at the at the customer level, with respect to analogy, or that is the waiting at the level of the product. So there could be many drivers of waiting actually. So the solving the problem of waiting is not straightforward. So waiting could be because of different reasons. It could be because of poor production planning. It could be because of poor maintenance of the equipment or machine. It could be because of poor forecasting of the customer demand. So we have to first understand the drivers of waiting and then target to eliminate them. The fifth waste is the overproduction, to produce sooner or in greater quantities than what customer demands. Some people say that this is the root of all manufacturing evil, according to Ono, one of the lean gurus. Overproduction is the major cause of problems in a manufacturing organization because it creates other waste. So overproduced items need to be stored. So that creates inventory. Also, overproduction results in greater movements or greater motions. It results in greater transportation. So that is sometimes called the mother of all waste. So it is also bad for inventory turns. Greater is the amount produced, of course, greater than what customer requires, then greater it has to wait within the organization. So inventory turnover will also be poor. It will be low. Products can be stolen, they can become obsolete. So there are many problems. So simple solution is match supply with demand. So it could be because of good forecasting, good production planning, and using the Kanban or pull system. The sixth one is overprocessing, processing beyond what the customer requires. Processing beyond what the customer requires. Examples are keeping a patient in the hospital longer than what is medically required. That is the example of a service organization. Finishing the job more than required. A customer requires a certain, for example, tolerance, but you are making the part at a more tighter tolerance, or customer requires a certain paint and you are making more than required number of coats of a paint on a product, or there could be many other examples. Customer requires simple packaging of the product and you are packing the product in very expensive sophisticated packaging that is not required actually for that product. So these are all examples of over processing. So it may result from internal standards that do not reflect true customer requirements. So it could be because you are not clear what actually customer requires. And it also may be because of undesirable effect of an operator's pride in his work. So um, even if it is not required, but the worker or operator can do it, so he or she is doing it because she or he can do it, but that is not required. So it could be because of unclear specifications, it could be because of unclear requirements of the customers. So it is important to have clear customer driven standards for every process. Because once we are over processing, so we are spending more time as well on that process. So ultimately the productivity will also get affected. The seventh is the waste of defect, the output not meeting the defined requirements. Reprocessing a part that does not fit in an assembly is an example of what we call a rework, because there are two types of defect: rework or scrap. So if the defect can be corrected, it is rework. If it cannot be corrected, it is scrap. Readmission to the hospital after discharge because the treatment was not up to the standard and the customer didn't recover. Failure to meet the do it right the first time. So that should be the goal of any process. Do it right the first time. And if we are not being able to do that, then we have to go for the rework. It can be caused by method, materials, machines, or manpower. Defect could be because of any of these factors. Rework requires additional resources so that normal production is not uh, rework requires additional resources so that normal production is not disrupted. So either you have to provide additional resources if you want the normal production to continue, or you have to stop the normal production and allocate those resources for rework. So that is also resulting in extra motions, extra transportation to correct the defect. So one waste produces other waste. So the solution is again to have clear specifications and to train the worker on that process so that defects are not reduced, to to have built-in quality checks in the process so that the part, if it is not made according to the requirements, gets rectified at the source. So that is what is called quality at the source. So that is a very strong concept, the concept of Jidoka, quality at the source. Faulty part does not move to the next workstation. We will watch this video during the discussion session. So this is the conclusion that 5 to 95 ratio of value to Muda is common in most well-established organizations. So there is just 5% of the time being spent on value-adding activities and remaining 95% is being spent on transportation, weight either in terms of inventory or because of availability of the resources, motions, unnecessary motions, of course, overproduction, overprocessing, and defects or correcting the defects. So even for many organizations, it is around 1% or even less than 1%. So these are the potential points of improvement. We have to target the 7 waste in order to increase the productivity. So that is to be kept in mind. There is an eighth waste as well. So you have to think and discover, explore what is the eighth waste, and that is very important as well. So what is the conclusion? The ultimate goal of work design or process design or industrial engineering as a whole is to improve productivity. The amount produced should be increased from the available resources. So reducing or eliminating waste contributes to increase the productivity. And that is the goal of this course, and that is the goal of discussing 7 ways. So if we can reduce them, we are ultimately increasing the productivity. So I will highly recommend you to explore at least 2 examples of each type of waste, and one related to service and one related to manufacturing operations. And it's better if you can find these ways from the daily life. Thank you very much.